Tutorial for Plant Detection Tool. Our new tool enables you to automatically detect crops and weeds across the entire field using AI detection. To begin, you can start from either the farm view or the fields view. Click Create New, then select Prescription. Alternatively, you can go directly to the field where you want to run detection and click Create Prescription. In both cases, after selecting Prescription, choose Analysis and then select Plant Detection. AI Detection. First, you'll have the option to run fully automated AI detection. In many cases, this model works well without any extra setup. To test it on your field, click Go to AI Detection. Then, draw a test area by clicking Draw Test Area. As you draw, you'll see rulers extending from the cursor to help you align your selection. The first click marks the top left corner. The second click marks the bottom right corner. The area must meet specific size conditions. As you draw, the system will guide you to stay within the allowed range. After drawing, you can delete or adjust the area by clicking and dragging its edges. Make sure the area includes all crop and weed types you want to detect. Once the test area is complete, the Apply AI Detection button will appear. Click it to continue. Review detection results. After approximately 10 seconds, you'll see the detection results displayed on the selected area. Now it's time to review them. Make sure the results meet the following criteria. No false detections are present. All weeds and crops are correctly identified and labeled. Bounding boxes fully cover each plant. No duplicate bounding boxes appear on the same plant. If you're unsure about the results, test additional areas in other parts of the field, especially where conditions like plant size, weed type, or soil differ. We recommend testing multiple spots to ensure reliability. To test another location, click Test New Area. If you're satisfied with the results, click Detect Whole Field to apply the model to the entire field. The tool will run detection across the whole area. If the results are not accurate or consistent, you can train your own model. Custom Model Training. Now we'll cover how to prepare and train a model that fits your specific field conditions. Section 1. Training Area. First, you'll need to create training areas, parts of the field used to train your model. You must define at least 2 training areas. Each training area should meet the following conditions. Choose areas with high weed or crop density. Select areas with diverse field conditions. Each crop or weed type should appear in at least 2 training areas. Click Draw Training Area to create the first one. Training areas must meet both minimum and maximum size requirements. Any additional areas can be added by clicking Add Training Area. You can adjust the boundaries of a training area after creating it by clicking its edges and dragging them. If the area is still empty, you can freely resize it. If the area already contains labels, resizing is limited to only increasing the size within the allowed maximum. Labeling options will become available once at least 2 training areas are defined. Section 2. Plant Classes and Labeling. You can choose one of 2 labeling methods, AI Assistant or Create Manually. First, we will cover the recommended method of labeling, which is using the AI Assistant. Our AI Labeling Assistant automatically pre-labels the plants in your training areas using a generic model. It will guide you through each previously created training area, one by one, to review it. At the bottom of the screen, you'll see navigation options that allow you to either discard the results for the area, this removes all labels from that area, or proceed to the next area. At the end of the review, you will be able to confirm the review process. If you discard the labels created by the assistant or create new training areas, you can rerun the assistant at any time by clicking the AI Assistant icon next to the area name. Creating labels manually. If you choose Create Manually, you'll be guided through the areas in a similar way as with the AI Assistant. To begin, you must first create at least one plant class by clicking Add Plant Class and naming it. You can continue adding more classes or begin labeling immediately by clicking Draw Label and selecting the class you want to use. When you finish labeling an area, click Next to proceed. After completing all areas, click Finish Editing to submit your labels. Labeling recommendations and requirements. No matter which labeling method you choose, each plant class must contain at least 10 labeled objects. If this requirement isn't met, you won't be able to proceed. To resolve it, either label more plants within the existing training areas or create additional ones by clicking Add Training Area. You can monitor these conditions in Section 2, Plant Classes and Labeling. This section shows the minimum number of labels required per class to start prediction. For each class, you'll also see a colored progress bar positioned at the top edge. The color of this bar indicates how well the class is prepared for model training. If the bar is red, the number of labeled plants is insufficient and you won't be able to run detection. If the bar is yellow, the number of labels may be acceptable but not ideal. If the bar is green, the recommended amount of labels has been reached and you have the highest chance of accurate detection. Edit labels. You can edit labels, whether generated by the AI or created manually, either during the guided review or later by clicking the Edit icon next to the training area name, or by selecting Edit Labels from the More Options menu. During editing, the following tools are available. Select labels. Click inside a label's boundary to select it. If a single label is selected, you can resize it by dragging its edges for more precise labeling. If multiple labels are selected, you can use this tool in combination with other tools. Inverse selection. Use it with Select Labels to quickly select all currently unselected labels. Draw labels. If a plant was missed, select the correct class and draw the label manually. These labels can be adjusted later, just like any other. Change class. With Select Labels, choose one or more labels and assign them to a different plant class. Delete. Once one or more labels are selected, click Delete to remove them if necessary. Test area. After labeling, once the required conditions are met, you can test your model. Click Draw Test Area and define one or more test zones across the field. We recommend creating multiple testing areas and including a variety of field conditions and labeled plant types to evaluate how the model performs under different circumstances. To add more zones, click Add Test Area. Once you're done adding zones, click Train and Test Detection to run the model on those areas. The process typically takes about 1 minute. Reviewing test results. Now you will be guided through each test area to closely review the detection results. You can switch back and forth between areas as needed. Once you've gone through all of them, options to proceed will become available. If you're unsure about the results, you can test your model in additional locations. To do this, click Test New Area. After drawing the area, click Apply Detection to run the model. This new area will be added to the existing test areas. Note that you can create up to 4 test areas in total. Train the model further. If you're not satisfied with the results, continue refining your model using the same approach as before. You can improve labels by adding, adjusting, or resizing them. You can also add more training areas, either by creating new ones or converting existing test areas into training areas via more options. After making any adjustments, run the model again on the test areas. Repeat this process as needed until you're satisfied with the results. Detect whole field. Once you're satisfied with the detection results, click a Detect Whole field to apply your trained model across the entire field. This may take a few moments. When complete, a new detection layer will appear in the CultiWise application. You can then use this layer to generate a selective herbicide prescription map or to run a plant count analysis. Now we'll go through some labeling rules to help you create the most effective and accurate labels. 1. Create or modify bounding boxes around the entire plant. Each box should fully enclose the plant. 2. Only one bounding box per plant. Avoid duplicates. Each plant or weed should be labeled once. 3. Label every crop. No crops should be left unmarked. 4. In dense areas, be as precise as possible, even if plant edges are hard to see. 5. Watch out for double boxes. Sometimes the AI adds 2 overlapping boxes when unsure of the class. Remove the extra one. 6. Delete all false detections. Any box that doesn't correspond to a real plant should be removed. 7. Don't overdo training. After a certain number of training areas, the improvements may be minimal. Minor mistakes can be filtered later when creating a spot spray map. 8. Include variety. Try to label areas with different plant sizes, row directions, soil types, and weed conditions, both in training and testing. 9. Combine hard-to-distinguish weeds into one class. If 2 weed types look very similar, it's okay to label them as one group. 10. Special scenarios. Label only weeds in homogeneous crop cover. For cases like overgrown weeds in cereals or grasslands, label only the weeds, not the crop. We hope you found this video helpful. If you have any further questions, feel free to contact our support team at support@cultiwise.com.